Okay, so we're going to practice expanding and condensing logarithms. Okay, so number one says expand or condense the following logs. And again, you can tell that this first one you have to condense it because it's already been in its expanded form. So the first thing that we're going to look for is before we can condense logarithms using the product or the quotient property, they cannot have any coefficients. So this 1/3 and this 4, we're going to use the power property to move it to exponents, and we're going to do the same thing for the 6 at the same time. Okay, so the first one, we get the natural log of x to the 1/3 minus the natural log of y to the 4th plus the natural log of z to the 6th. Okay, now that we have two logarithms, the natural log and natural log with no coefficients, they have the same base, we can use the quotient property here and put them together. Now also the 1/3 is the same thing as the cube root, so we get the natural log of the cube root of x divided by y to the 4th. Okay, and that's all in parentheses plus the natural log of z to the 6th. So I'm preserving these parentheses that we had inside. And then the last thing we're going to do is we're going to put, now we have this log and this log, we're going to, with the addition in between them. So we're actually going to put those together using the product property into one logarithm, and it's going to be the cube root of x over y to the 4th times z to the 6th. Okay, and that's what you're finished with. Now, the next one. Obviously, we're going to expand this one because this one has one logarithm. So we're going to use this log, base 10, the common log, and we're going to expand it out. So there are parentheses on the top and the bottom like this. So the first thing that we're going to do is expand that division. So we're going to get the log, and I'm also going to change this 1/4 power, or the 4th root to the 1/4 power. So we get this to the 1/4 minus the same logarithm y squared. Okay, and now I'm going to use the power property for this and move it to the front. So I get 1/4, and putting this in parentheses like that, minus 2 log of y. Now I have this multiplication here, this times z times x squared. So again, I'm going to use the product property, z plus the log of x squared inside the parentheses minus 2 log y. And now the last thing I have to do is move this exponent, so my final expanded log is 1/4 parentheses the log of z plus 2 log x minus 2 log y. And that's our fully expanded logarithm. Number 3, we're going to be condensing because you can see that we have a bunch of logarithms. We're going to condense it down to one. So the first thing we're going to do is we're going to deal with this. We're going to move it to the power to get natural log, and then we're going to do these powers here and here too. Move it there and there. Okay, so I end up with natural log of x plus 2 cubed minus parentheses the natural log of y squared plus the natural log of the square root of z, because that's going to be the 1/2 power and it makes it the square root. Okay, now I'm going to condense what's inside the parentheses before I deal with this subtraction outside. So x plus 2 cubed minus, and this condensed down to one log, which is the natural log of y squared square root of z, like that. Because addition means multiply, so multiply y squared by square root of z. And then the last part, dealing with the subtraction using the quotient property, bringing it down to one natural log of x plus 2 cubed over y squared square root of z. And that's your final condensed log. Now, the next two, we're going to be using log properties to simplify and then solve. Okay? So, for number 4, I have two logs. They both have base x, so I can condense those because I have addition using the product property. So I get the log base x of 12 times 3 equals 2. Okay? And of course, 12 times 3, log base x of 12 times 3, that is 36 equals 2. And now we're going to use the changing the logarithm to its exponential form. So remember, it's x to this power equals that. So when I change it, I get x squared equals 36, which means x can be equal plus or minus 6. So those are solutions. And of course, you can see that when you plug 6 in here, 6 to the second power is 36, and negative 6 to the second power is 36. So both of them work. Oops, sorry. And then the last one, if my computer will work. We're going to use some log properties here. Okay? So on the left, first thing we're going to look, if we have the same bases on both, if we have, say this was base 10 and this one was base 10, we could drop the logs altogether if they have the same bases. But since they don't, we got some more work to do. But I can see right here, I have log base 10, 10 squared. Now, that's one of my identities. This right here is this identity. If you have log base a of a to the x, that equals x. That is one of our inverse identities. So since the bases match, I'm left with 2 equals the log of x minus 2, 16. Well, again, I have a log with just a number on the other side, so I can change it to its exponential form. So it's this to this power equals that. So we end up with x minus 2 squared equals 16. Okay? So we got to solve for x, so we FOIL this out. We get x squared minus 4x plus 4 equals 16. Subtract 16 from both sides. We get x squared minus 4x minus 12 equals 0. And so this, let's see, is it factorable? So we have x and x. Factors of 12 are 1 and 12, 2 and 6, 3 and 4. Since this is minus and this is minus, this is a difference. So which has a difference of 4? It is 2 and 6. The bigger one's going to be negative. So our solutions are x equals 2 and x equals 6. And those are our solutions. So sometimes we just use the properties to find our solutions.